Hello everybody. Now let's discuss one more important topic in the V model. This is a part of the V model. This is a subset of the entire algorithm development. Alright. Now let's see this ADA software code model based development. What is this model based development? What is this manual code development? How do they relate to each other? How is one advantages over another? All these things we will discuss in the next two sessions, including this. Advanced driver assistance systems are complex automotive systems that require rigorous development methodologies to ensure safety and reliability. The very purpose of ADAS is to add safety to the driver. So naturally, the algorithms that are being used, they require rigorous development, rigorous testing, rigorous verification and validation methodology. And more importantly, they must be highly reliable. Okay, not only reliable. Now, as competition is going higher and higher between the OEMs, the pressure on the OEMs to release the software as quickly as possible into the market is also enhancing multifold. That is where this model based development comes into picture. I will explain to you what is model based development in a very elaborate manner. First of all, let's see what are the two primary approaches that are used in ADAS development. Model based development and traditional code development. These are the two ways in which ADAS software is developed, ADAS code is developed. These approaches are sometimes combined in modern automotive software engineering. Usually, model based developments should suffice. Actually, more and more OEMs are moving towards model based development as a part of code, but still for some applications where optimization level is not that high, traditional code development is also used. Now, what is this model based development? Model based development is a methodology where system models serve as primary artifacts throughout the development process, from requirements to implementation. I clearly explained to you what is meant by requirements already. So based on the requirements, models are prepared in MATLAB or Simulink, and directly from that model a code is developed. Okay, let me further elaborate. Especially for ADAS system, this approach is particularly valuable due to complexity of algorithms and need for extensive verification. Now this is something I touched upon. Extensive verification is required and complex algorithms are mandatory. Okay, so in model based development there are three aspects. One is system modeling, other is simulation, and other is automatic code generation. Of course, some people opine that third step is also automatic code validation also. Well, that also we will briefly touch upon. But here let's discuss about this automatic code generation. So system modeling is you prepare a high level architectural models using MATLAB or Simulink or SCADE or IBM Rhapsody. IBM Rhapsody is useful for SIS level 3 architecture also. Okay, and these behavioral models representing ADAS functionality. The ADAS functionality can be lane keeping or adaptive cruise control or automotive emergency braking or blind spot detection. All these functionalities can be represented by behavioral model, and even this behavioral model includes the environment models for sensor simulations like camera, radar and lidar. All right, next is simulation environment, and once this plaid model is developed, it represents the vehicle dynamics, the velocity, the torque, the acceleration. All these things are developed with the help of a simulation environment. Sensor modeling with realistic noise and distortion characteristics, scenario simulation, urban highway and edge cases. Okay, so all these various types of use cases, whether it is urban use case or highway use case or some kind of a guard section or a mountain valley use case, all these kind of simulations can be simulated in the simulation environment. And what are the various tools which are used in simulation environment? CarSim, FreeScan, various VTD, NVIDIA Drive Sim. These are all the various types of simulation environments. Okay, in this simulation environment and based on the system modeling, directly the production code is generated from verified models. All right, and it is further optimized for automotive processors like RX or Renesas or Infineon. All these automotive processors are kept in mind when the automotive code is generated. Compliance with the automotive standards, and of course the software which is developed, it must be perfectly compliant with the various standards like ISO 26262, MISRA C. All these automotive standards are need to be kept in the mind when this software is developed. Okay, now in case you are wondering how exactly code is generated, let me tell you in a very simple language. Based on the model, once the model is built, once a behavior model is built, there will be one small button in the MATLAB. Once you press the button, automatically the code is generated. Okay, let's not go deep dive how the code is generated and all. That's actually not necessary also. So just keep in mind, instead of writing the code directly right from the starting, you build a model, behavior model in MATLAB, and from that MATLAB model directly code is derived. Alright, that much knowledge should suffice for now. Now, what are the advantages when it comes to ADAS? In ADAS, what is the advantage when it comes to model based development? The biggest advantage is it is early validation, because the software is developed very fast. The algorithms also can be tested in simulation before the hardware availability. Before the software is embedded into the entire MCU or ECU, this software code or algorithm can be simulated and tested and validated. Next important thing is reduced errors. The automatic code generation minimizes manual coding mistakes. Okay, now this is more like common sense, because when a human being sits in front of computers and writes a code, 200,000 line code, naturally some mistakes will creep in. That errors are drastically reduced with the help of model based design. Next comes parameter tuning. All the various parameters like PID controls for braking are easily adjusted. Torque controller for acceleration, all these can be easily adjusted with the help of model based development. Reusability, and these models can be reused across projects and platforms. See, across various platforms, these models can be used with subtle variation. You don't need to build a model from scratch for every platform. For example, in the same OEM manufacturer, let me take one example. Suppose there is in Hyundai, there is a car called Hyundai Creta, and there is slightly higher version also called Hyundai Tucson or Tucson. I don't know how the pronunciation is. So from one project to other project, or one platform to other platform, no need to build a model from the scratch. Subtle variation will also suffice. Okay, but having said that, there are some challenges. It's not that model based development is totally foolproof and it does not have any obstacles. The biggest challenge is model fidelity versus real world performance. This is the biggest concern. Okay, you prepare a model, but all of a sudden it's only simulation. So there is definitely a gap between the fidelity or the efficacy of the model and the real world performance. Computational requirements for high fidelity simulations. Toolchain integrity complexity. This is also biggest challenge. Okay, and next is configuration. Okay, let me explain this toolchain integrity, because different tools are being used. So the data which is coming from one tool may or may not be compatible for other tool. So this is one important challenge which model based development is facing. And next is certification of auto generated code. Okay, the code is automatically generated, but how quickly is it certified? How certifiable is it? All these things are the challenges which model based development is facing as of now. Now let's slightly discuss about this traditional code development. Frankly speaking, this traditional code development is fast becoming obsolete, but still, as I said, in the applications where there is low level optimization, traditional code development for ADAS is being used. The three important aspects of code development is: first, algorithm implementation, manual coding of computer vision algorithms. Next is sensor fusion implementation, control algorithms for vehicle actuation. The algorithm implementation is the biggest challenge or biggest aspect of the code development. Next is hardware specific optimization. Processor specific optimizations like SIMD instructions or cache optimization. Next is GPU acceleration for neural networks, memory management for resource constrained systems. All this hardware specific optimization are the biggest aspect. I mean, first, once you develop a code, it must be optimizable for all these hardwares. Last but not the least, safety critical consideration. It must be compliant for with MISRA. It should be compliant for the ASIL level D, and it should also be defensive programming and fault detection mechanisms. Always remember, fault detection mechanisms are very important because there should be some integral or inherent mechanism through which fault can be detected and also be informed to the driver as and when fault occurs. Now, well, even though this manual code is becoming obsolete, still some performance, some advantages hold good. The biggest advantage is performance control. Because it is being written manually, it can be fine grained for critical paths. For some critical paths, it can always be fine tuned. Next is legacy integration. Okay, so for various tools, it can easily be integrated. Next is hardware specific features. So because you are manually writing a code, you can be rest assured that the code is directly compatible with the hardware. And biggest advantage is deterministic behavior. So once you are clearly aware of the real-time system, the deterministic behavior can easily be analyzed, determined and identified. So based on that, the code can be written manually. But there are some challenges, or actually these challenges are fast overwhelming the advantages. The biggest challenge is longer development cycles, higher potential for human error in manual coding. This is something which I already said. If you are writing a code for some 1000 lines or 2000 lines, definitely inevitably some human error will creep in, irrespective of the efficacy of the coder or the software programmer. Okay, more difficult to maintain and modify. Okay, and last but not the least, it requires extensive testing to achieve safety certification. That is the reason. I mean, because both have its own advantages. Both the methods have its own advantages and disadvantages. Many OEMs are even today slightly using combined approach in modern ADAS development. Okay, so for high level algorithm development, MBD model based development is used. Low level components, manual coding is used. Computer vision, again it is a hybrid approach for both model based design and also manual coding, and also for neural network, model based training, manual optimization for development. All these things are very important. Okay, so these are the various applications for which the modern application for which combined methodologies is being used. Now, what is the typical workflow? What is the typical workflow right from requirements to user end testing? Well, this is something which I already touched upon or in the in-loop testing, but just for revision, we will see here also. First is requirements capture, system design, algorithm development in simulation environment. Next is software in-loop SIL testing, hill testing, automatic code generation for control algorithms, manual optimization of critical components, integration with AutoSAR architecture. I mean, this is very important. I mean, what is AutoSAR? AutoSAR is nothing but a common platform for which the software is being developed. I will briefly explain to you what is AutoSAR. There is a separate section for AutoSAR. I am sure you will learn what AutoSAR is. Now, validation on prototype vehicles. Now, these are all the typical workflow in which a software can be developed, or algorithm or a code, whatever name you want to call it, can be developed.